I want to say welcome to Nile Engineering YouTube channel. In my today's video, I'm going to do Ansys mechanical analysis on truss element. So the problem is this truss structure. Here the youngest modulus for element number 1 and element number 2 is 250 gigapascal, and also the Poisson ratio is 0.3, and throughout the lengths for element number 1 and also element number 2 the area is constant. That one is 400 millimeters square. Our aim is to find the displacements and also the nodal reactions and the elemental stresses. Now let me go through the steps one by one. Now go back to Ansys. Then here we do have files tab. From that one you have to clear and start new. Click this one, and do not you have to click on do not read file. Then okay, then yes. Now I have to save this analysis somewhere else in my personal computer. Here go to save as, then here we do have C. So I'm going to save this one on this folder, then say okay. So first of all I have to provide the name, Truss example 1, then okay. Now the analysis is saved. Then we have to go to preferences, then structural, then okay. Then after go to preprocessors, then go element type, then add, then link, and then after okay. Then cancel this one and minimize this one and go to material properties. Then from that we have to go to material models. Okay, it is the same step that we followed for the bar element. Here it is. From the problem we have 250 gigapascal, so this is 2.5 e raised to 5 megapascal. So go back to Ansys. Then here it is 2.5 e raised to 5, then the Poisson ratio is 0.3, then okay. Then cancel this define material model behavior, then go to Ansys, then minimize these material models, then go to sections. From section go to link, then add. Here it is 1, then okay. This area, the area is constant, that is 400, then okay. Then minimize section and go to modeling, then after create, then nodes, then inactive coordinate system. Then this one is node number 1, that is 0, 0. Then apply. The second node is 2. That one is from the problem. Here we have what? The first one is 0, 0. The second one is 800, 0. The last one is 1400, minus 500, because here along x-axis, when we measure from this node number 1, this one is 800, this one is 600, this is totally it is 1400. Then the y-axis, from if the axis is at this node number 1, so it is below the positive y-axis, so it is minus 500, because the length from the origin of x-axis to this point is minus 500. Okay, then accept this one as it is, apply. Then after number 2, it is 800, 0, then apply. On number 3 is 800 plus 600, then comma minus 500. Then we finished all the nodes. Then accept this one by clicking on OK. Then minimize nodes. Now as we see on the screen, we have those 3 nodes for the elements. Then go to elements, then element attributes. Okay, we only have a single area and also material type. Then accept us by saying OK. Then go to auto number, then the true nodes. Then click the first one and the second nodes. Then apply. Then the second node and the third node. Then accept by saying OK. Now, because the material property and the cross section is the same, it is possible to finish the 2 elements in one command. Then after minimize elements, minimize modeling. Now go to loads. Then after define loads, then apply. From apply structural, and from that one displacement. Now we do have 2 fixed boundary condition here from the problem. This one is fixed and this one is fixed. All the nodes should be fixed. Okay, then go to on nodes. I'm going to apply on this one, apply. Okay, all degrees of freedom. Okay, then on the second one, it's on this one, then OK. Then on all degrees of freedom. Okay, now we have applied 2 fixed boundary condition. Then minimize displacement and go to fix and go to force and the moment. Then on nodes, I'm going to apply on this node. Then OK. Then after, the direction of application is along FY, it is along y-axis. So click this one. I have to provide the magnitude. The magnitude is minus 50 kilonewton. That is 50,000. Then say OK, because from the problem we have what? We have 50 kilonewton. This one is minus 50,000. Now go back. Now all the boundary condition and the force is applied. Then minimize structural loads and go to solution. From solution solve. From solve current linear static. Then OK. Then as you see, the solution is done. Then close this one and also close this one. Then minimize solution and go to general post processor. Then from that one go to result viewer here. And from this one choose stress X component. Then close this one. Okay. Now go to element table. Then go to define table. Then from that one go to add. Then after go to by sequence number. Go to wordless and provide 1. Then say OK. Then cancel this one. Go to I think we have finished. No, go to a list element table, then go to ls. Okay, this is the element result, and we have to see it one by one in the plot in the list result. Now let me go to plot results and go to deformed shape, then click the second one and okay. Now we have the first one is the first line with white dotted type is the original one, and the second one, that one is in the blue sign, is the deformed shape. Okay, now let me change the background, plot control, then style, and go to colors and reverse video. Now it is in white background, and then after we have to go to counter plot, then after nodal solution. From nodal solution we have to go to degrees of freedom solutions, then X component, then okay, we have this solution result for the displacements. Okay, this one is when we see along XY component. Okay, we have the maximum and also the minimum result. Then go to element solution, and then after solution stress, then X component stress, then after okay. Now this one is the stress along X component. Now go to element table, because it is in this result is showing the stress result as a common value. So go to element table, and then after provide this one and say okay. Now here we have different two elements. Okay, sometimes it cannot show the correct result on the element solution, so we have to go to element table, and then after at that point we have two different amounts of stress for each of the elements. We can make this one as 3D, okay, but in our case this one is enough, because in the stress element we cannot show the 3D geometries of the stress element, so we simply represent by line representation. Okay, now we finished for the elemental table. Then go to list results and go to nodal solution, and then after here we have this one is for displacement and this one is for the stress. Then go to the first one and X components of displacement, then okay. Now we have the list of results of the displacement at node number 1, node number 2, and node number 3. It is possible to save this one, file, then save as. Okay, here it is. In my case I'm going to save this one. Here I'm going to save this one, my Truss element folder. This is list of nodal solution. Okay, then save. Now cancel this one and go to element solution, then after stress, then X component, then okay. Here we have the result for the stress in each of the elements. Now for the element number 1 we do have 2 nodes, so that the magnitude of the stress is the same, it is minus 1/50. For the second element the same applies, the magnitude is the same at each of the nodes, that one is minus 195.26 megapascal. Okay, cancel this one because we provided the magnitude of Young's modulus by megapascal. Here, the results for this truss should be in megapascal. So then cancel this one. Okay, now we finished. If you need to save this one in any folder that you like, go to plot control and then after go to capture image. Then from this image, this is simply image, then go to file, then after save as, then here it is stress plot stress results. Okay, this is the name. I'm going to save this one in my truss element folder, then save. Okay, this one is saved, and cancel this one and go back to the Ansys. The same applies for the displacement. You can save the plot results of the displacement as we have seen in the bar element and so on. Okay, this is all about the analysis for the truss element on Ansys mechanical APDL. Okay, thank you for your time, and in the coming videos I'm going to show you somehow complex elements of truss structure. So in that case we may consider different types of problems. For example, here we do have one problem. Okay, this is somehow complex than the first example. So in the coming video I'm going to show you how to do analysis on this truss structure. Okay, for today this is enough. Thank you very much for your time.